Bueno, buenas tardes a todos. Muchas gracias por venir, los que podéis estar aquí y aquellos que estáis conectados online también. Estoy muy agradecida a los Liber Seminars por haberme invitado a hacer de anfitriona y más en un día tan especial como hoy, que celebramos el 5º aniversario. Y además estoy doblemente agradecida y emocionada porque os puedo presentar a nuestro speaker, que no necesita una gran introducción. Todos aquellos que trabajáis en el campo de las enfermedades hepáticas lo conocéis. Es el doctor Heiner Wedemeyer, que es el director del Instituto de Gastroenterología, Hepatología y Endocrinología del Hospital Universitario de Hannover. Ha hecho contribuciones relevantes en el ámbito de las enfermedades hepáticas y sobre todo en el campo de las hepatitis víricas, y de hecho la charla que le hemos pedido que nos dé hoy es sobre hepatitis delta y obviamente es un tiempo muy adecuado para hablar de hepatitis delta, ya que hay novedades en cuanto a la patogénesis y en cuanto a nuevas dianas terapéuticas. Su trayectoria científica la conocéis probablemente muchos de vosotros también. Ha contribuido a la publicación de más de 500 artículos, más de 100 revisiones y tiene un H-index pues, muy elevado, reflejando pues, la calidad de sus contribuciones científicas. So Heiner, welcome. Thank you for coming. I know that after the intense week that we had at the ILC last week in London, it's been an effort for you, so we really appreciate that you're here today with us. So for the people that are online, please remember that after the session we will have Q&As, and you can ask through the chat, or you can kind of raise your hand online, and I will be able to open your micro so that you can ask Dr. Wedemeyer any question that you have. Thank you. The stage is yours.
So thank you very much, Sabila, and thank you for a wonderful day already. Seeing the liver unit here, the different departments, is really impressive. And I think there are many parallels between Barcelona and Hanover, because bringing people together, thinking both from the clinical perspective as well as performing some translational work is so important, and that's you cannot find it many places. It's very nice, and therefore thank you very much for the invitation. And this is Hanover Medical School. I just wanted to show you the environment where we are, and what you experience here is bringing together translational basic scientists with clinicians, and I think you need an environment with exchange. So what we have here in Hanover is this is the hospital, and my office is basically here. Here's the endoscopy unit. And the transplants are performed in this building. There's also a transplant ward. This is the infectious disease ward, which you can see here. But we have a lot of basic research buildings. And for example, here you can see an institute which is dedicated to infectious diseases. It's run by the Helmholtz Institute. And Markus Kornberg, who's my deputy, we're working closely with him together. He has his lab, for example, in that building. I have my lab very close to the endoscopy room, so I don't need to walk. But you can also see it's a nice environment. Hanover Medical School, we will have a completely new built hospital, which is here. So here you can see the small gardens, which no longer exist. They've been broken down, and here we will build a new hospital. But Hanover is a really green city. I'm living here. So I don't have a car. I go each day by bike or running through this wood, which is actually quite convenient, I have to tell you. So that's neat. And here we have also other interesting building on the very right. You can see here this building within the shape of a brain, which is a private brain neurosurgery building. It's also something that has been developed there, but it's a nice campus. We have also other basic research institutes, and this is, I think, maybe one of the most important messages. We have to talk to each other. We have to bring basic scientists and clinicians together, and that differentiates us from purely basic science research institute or purely, let's say, teaching hospitals. So I have to indicate some conflicts because, and this is not a conflict of interest slide shown for 0.2 seconds. I advise companies designing trials for hepatitis B or D. And I think this is important that we talk with academia, with industry, to avoid also mistakes. We have to tell them how to design trials in steering committees, and I think that's also part of the exchange. And today we'll talk about hepatitis D virus infection, which is really amazing story that the basic virology had an idea that a small startup company was developed, that, let's say, we developed clinical trials, that big pharma, let's say, acquired the small company, that we have a new treatment. And now we're going back to the lab. We have this drug in our hands, and that now we are asking completely new research questions, identifying biomarkers where we may use this new treatment. And I think this is a prime example how translational research can be from both, from all different aspects. And obviously, this is something that we are working on different levels. Many people from Hannover Medical School are working together here. I mentioned this new Institute for Research, Yang Li, Markus Cormack, Jennifer Debarry. I will come back to this. And we have obviously international collaborations. This is my hepatitis alphabet. I'm always showing when I give talks to general practitioners. A is acute. We have outbreaks, maybe even among distinct risk groups. B, I changed the wording for B because 3 years ago I was writing there boring. Because we were just using one pill a day, no side effects, every 3 months a prescription, patients do fine. What is left? But B is back. B is back. There's so exciting research also to achieve cure for hepatitis C. C is curable, but not mission completed. E is emerging. It's really something where many cases are showing up. Just Markus Komberg just sent me a WhatsApp that we have a patient with acute on chronic E on our ward, where she may be at the edge of maybe being enlisted for liver transplantation at this stage. But D stands for devil. And I think there's no discussion that Delta causes the most severe form of viral hepatitis. And it's an orphan disease, and therefore we have to have seminars like this. We have to exchange experience to learn for individual patients, and also maybe to harmonize research questions. I made up a case. So Victor is very close to many patients I see in our clinic in Hanover. He was born in Uzbekistan. When you treat Delta in Germany, you have to be very good in geography of Central Asia, Uzbekistan, Tajikistan, Kyrgyzstan. We are all these countries. We have many immigrants carrying Delta. Obviously, the usual story, had been infected with B for more than 10 years, still hepatitis, tenofovir was given, nothing happened, and nobody thought about Delta. Obviously, a Russian guy should not drink so much alcohol. That was a usual statement, and Delta was only tested 12 years later. And I think that's maybe the most important message of this talk. If you should implement, we discussed this in the Delta meeting during EASL, reflex testings or other ideas, we should not miss Delta, because it's now even more important than before, because there are treatment options. We now know much better to deal with these patients, which maybe had less consequence 10 or 20 years ago. Delta is this strange virus, which is on its own, it cannot survive. It needs other envelopes. And I think this is maybe something that we are overlooking in medicine and biology. Maybe there are many more Delta-like viruses, small virions, defective, which hijacks other membranes to disseminate and to spread. This is, let's say, we have learned over the last 10 years, for example, that hepatitis A and hepatitis E, they also hijack membranes. They hijack host membranes. And the mechanism there is to be protective probably from immune responses. But here, a membrane from another virus is used to transmit the virus. It's the numbers, how many patients we have worldwide, have been debated over the last 2-3 years. There have been strange meta-analysis using published data in a rather uncritical way, coming up with numbers like 70 million people worldwide being infected, so more hepatitis Delta patients than HCV patients worldwide. I think we can question this. Therefore, I strongly recommend a review paper by Alex Stockdale from England, and I think they came up with a number of 12 million, and which I think is a reasonable number worldwide, and it causes the most severe form of viral hepatitis. And for the fellows in the room or online who have other skills than just being in the lab or in the clinic, if you have other things, then you may also give an imprint worldwide. This nice cartoon was painted by a med student from Spain working at Hannover Medical School. Maria knows her, Beatriz Calderano, and I'm always showing her pictures, and I think it's a very nice structure. The S antigen and the Delta and the rod-like structure factors and so on. I think it's a very nice picture. She did more of them. I still have them in my office. So delta is rare, but is also heterogeneous. So we are talking about at least 8 different genotypes worldwide. We have also different, let's say, epidemiological backgrounds, different environmental exposures, which makes it complicated. So is there one-size-fits-all therapy? What is the risk for disease progression? And therefore, when we interview patients, my patient Victor was from Uzbekistan. And then the question is he just came to Germany, has been exposed to other viruses over there? What's about African immigrants? There may be additional risk factors which we may overlook, and therefore everything starts with a good diagnostic workup and then medical history, and this may be even more important for Delta patients. And then you may ask, okay, Delta, different regions, hepatitis B, we have also different regions, different genotypes, so can each Delta genotype get along with each HBV genotype? It's not a trivial question. So we are talking of HDV genotype 1, probably most prevalent here in Barcelona. But what's about other HBV genotypes? Can the genotype 1 with Delta go along with HDV genotype 1, 2, 3, 4, 5, 6? And therefore, I like really this work by Stefan Urban from Heidelberg, where he has been mixing the 8 HDV genotypes with 8 HBV genotypes. The short message is everything is possible, but there are differences. There are differences in terms of replication efficacy, and therefore we may think, we should not forget that when I talk about Delta, that always this is on the backbone of hepatitis B, which may impact also the natural course. And then the final introductory question, so Victor has B co-infection, but was B really the cause for HDV transmission? You may ask, what is he talking about? Delta is part of the HBS antigen. And I'm talking about a Nature Communications paper from Françoise Cosset published 3 years ago, where she in vitro and also in animals was able to transmit Delta with other envelopes than S antigen, which is really weird at that time. So what's going on there? And you can see this here, VSV and hepatitis C. And now you may ask, can Delta be transmitted by hepatitis C? Do you now have to screen all the ID physicians treating drug addicts? Have they to screen all the hepatitis C patients also for Delta in the absence of hepatitis B? And I thought, okay, that may be a nice, let's say, experiment in the lab, has no clinical relevance. I have never seen a C patient without B markers. There have been some people now screening cohorts, rare cases, and I thought this is a lab artifact. Doesn't matter. Until I saw this paper in hepatology last year. So they screened in Venezuela patients with hepatitis C without any hepatitis B marker and found 2 Delta patients, one viremic. It was not a strange Delta genotype. It was really genotype 1 infection. So can it occur more often than we thought? Here also, I'm not claiming that Delta was transmitted in these 2 patients by C. It may well be that they had C, but the cause was maybe of a different other viruses. Yellow fever, I have no clue that Delta may hijack that one. Just keep it in mind. I don't think that this is a major clinical problem, but we have to be aware of this, that we are talking about something where maybe completely unexpected things may develop. I think it's just interesting. So, Victor has hepatitis, as you can see here. And the next question for us in the clinic, obviously, what have you to do? So what is the workup of a Delta patient? Obviously, you have to first test for virus, RNA. And this is not trivial. Only since 3-4 years, we have commercial assays, which are highly sensitive. But even if experienced labs use the same assay, they may get completely different quantitative results. It's not that well standardized, and therefore, if you see a patient referred from another center where you don't know what the viral loads are, you cannot really say 10,000 units is 10,000, or there is no cutoff that 10,000 units is bad and 100,000 units is even worse. We don't have these quantitative values which we can link to clinical outcomes. We have to do our virology homework, our homework in terms of liver disease. And then the last point is that Delta also can cause some kind of autoimmune phenomena. Delta has been linked with higher frequencies of autoimmune hepatitis, and this is of relevance. You have a fellow from Greece here right now in Barcelona, and in our first New England Journal paper, which we published with interferon, there was one patient in Greece developing severe autoimmune hepatitis. Kalliope Sakhou and George Dalekos had to take a patient out of the trial after 12 weeks, and this really matters. And on the other way around, Pietro Lamberti could just publish, when using bulevirtide and delta, that markers of autoimmune hepatitis, surprisingly high IgG levels, really declined fast during bulevirtide treatment. So this is something which we should not forget and have in mind. I skip this one. Low levels of viremia can be detected in delta. And this matters. So you have some patients with high viral load, other patients with undetectable. But if you apply very sensitive assays, you may detect trace amounts of virus. And this, we published this last year, that this matters because these patients may have a higher risk when stopping treatment. And this may become even more important, these highly sensitive assays, now when we're talking about new treatment options, where I will come back to the question, can I stop bulevirtide at a certain time point? And my answer is maybe yes in some patients, future will show, but then you have to apply the most sensitive assay available, which is really critical. So these guys in the middle, these orange guys, they relapsed because they had a low level of viremia detectable during treatment. They were initially classified as undetectable. We also have to keep in mind that there are a variety of hepatitis B markers, which we may use in hepatitis D. This is just one example where we looked for HBV core-related antigens, and this was surprisingly good associated with response of delta to interferon treatment. So we can maybe discuss later what this means biologically, but when we want to personalize treatment for hepatitis D, we have to take all parameters we have, and correlated antigen could be something. So now let's talk about Victor. Do we have to biopsy Victor? He has let's imagine he has a FibroScan of 19, he has platelets of 135, so very likely compensated cirrhosis. Would a biopsy help us, yes or no, in the clinic? I think that this guy has treatment needs, I think there's no doubt, but should we biopsy Victor? And you can have a vote here, and maybe half of you would say yes, the others say no. Why should I take any risk in this patient? And there are many arguments in both directions. I biopsied Victor, and that was at that time because we still considered interferon, and I wanted to exclude the risk for autoimmune hepatitis in this patient. Also because he had maybe other risk factors, alcohol, etc. I wanted to be really sure what I'm doing, therefore I biopsied. But this may change as we did in hepatitis C. 15 years ago, we were biopsying most patients, and we did not biopsy them anymore later on when the treatment indication was clear. We just have to learn, and this is something we may discuss. So now let's move on. So we biopsied, indeed he had liver cirrhosis, he had no features of autoimmune hepatitis. But for Victor now the question is, he is afraid maybe of interferon. So what are Victor's risks to develop clinical complications? Will he really die from cirrhosis? Yes or no? Is it very fast progressing, slow progressing? What are the data that have been published? And there are obviously quite some single center cohorts. This is data from Sweden. It's almost population-based, so they cover many patients, most likely more than 50 to 60% of Delta patients registered in Sweden. And then this was a retrospective prospective analysis with the outcome. And you can see here, if a patient has liver cirrhosis, Victor, the outcome would not be good. After 5 years, at least 50% of the patients had already developed a clinical event. But on the other hand, not every patient takes a severe course. You can see here, if no cirrhosis is present, it was rather benign. But so where do we know? Victor, I biopsied, he had cirrhosis, but if he would have now F2, F3, would he still belong to the first group? Would he be progressive? And that's really something why we need registries. We need to combine data. We need to understand individual courses. And then also virological assays are important, and published here in Spain. Last year, I think it was the APNT paper, which I think is very nice, that some patients may even without treatment lose spontaneously over time also HDV RNA. So we have to keep in mind that there is an evolution, and Paco also nicely published that this evolution over time may change the virus, so that the likelihood that the virus may change and develop and that quasi-species develop is not linear over time. It changes over time. Paco and I copied this graph, which is from the paper, which I think where you can really see nicely that you have in the first years, there's a high evolution rate, which over time in the long term is declining. And therefore, it's also again, we need to know more about the patient. Is he stable? Is he in this early phase where you still have fluctuating courses? And Maria, this is from your J. Hepatol paper 10 years or 12 years ago, where basically the message is here, everything can happen. You may have patients who are stable with both viruses over time. You may have some patients slipping around. And the question is really, why is this happening? Why is Delta interfering with B? What are the mechanisms? There may be, let's say, indirect mechanisms, immune-mediated mechanisms. There may be also direct interference that distinct HDV antigen may interfere with HBV enhancers. Everything has been suggested, but overall we don't know it. But what is important, if you therefore we have to do our HBV homework. A Delta patient where D is dominant has a different inflammatory milieu, as we've been showing here, as compared to a Delta patient where B is dominant. And this may then also impact the clinical course. I think all these factors we really have to keep in mind, and more work is really done also in the liver, what is ongoing. This was very simple Luminex testing, already giving some hints that we cannot put everything in one pot. We really have to differentiate all the subgroups of Delta. And finally, Delta also increases the risk for cancer. 10 years ago, when I gave educational lectures, I was stating, yes, Delta, more severe liver disease, earlier cirrhosis, therefore also a little more cancer. But there's more and more evidence that Delta itself may also increase, irrespective of the cirrhosis states, give some additional hits for cancer development. And therefore, Victor, coming back to Victor needs really very strict cancer surveillance. At least every 6 months. He is at risk to develop liver cancer. We talked about liver transplantation today, and in Hanover, we have pretty much the same numbers than you have here at this center in terms of liver transplantation. When we think about viral hepatitis, the most frequent cause for viral hepatitis and liver transplantation was Delta. We have been, with active hepatitis transplanting in the last year, more Delta patients than hepatitis B patients. So it's really a clinically relevant disease. Now Victor is asking, okay, bad luck, but why did I develop liver cirrhosis? I didn't know. Yes, I was born in Uzbekistan. I drank some alcohol, but he is not an alcoholic. So he is not the guy drinking 3 vodkas an evening, moderate social consumption. But why Victor did develop cirrhosis, others did not. And I think you may then first start with the virus. Are viruses different? And are different viruses associated with different outcome? And the answer is yes. We are talking here in almost all cases of genotype 1. This is bad because this is the bad virus. For example, genotype 2, which is frequent in Eastern Asia, has been shown 15 years ago, may take a milder course. Genotype 5, which is present in sub-Saharan Africa, also takes a milder course. This is data from King's, where they analyzed this one. So we are talking about the severe genotype. It cannot change. Whether there are differences in subgenotypes, genotype 1A versus D, a matter of debate. But in general, genotype 1 is a severe genotype. Host responses. And there is really big space. I think we need many more studies to really understand the role of distinct immune cells in Delta. We started the first projects 10 years ago. We did the usual screening. We compared hepatitis B, C, D. We did, at that time, we were very proud to have a 12-color flow cytometry, and that was exciting. We showed that NK cells were compromised really in function, in particular in Delta. That was the first study. We then went a little further and investigated NK cells in more detail. We could show that the CD56 bright NK cells were increased in HDV infection, like in many other infectious diseases. However, these cells were really impaired in function, and in particular, we lost the terminally differentiated cells when the patients were treated with interferon. And when we applied interferon, then we could really detect the polarization of NK cells towards phosphorylated STAT1 to really investigate a little more the function of these NK cells in the context of Delta treatment. This was also associated with subsequent response. So indicating NK cells could play a role. In the long term, obviously, the question is, can we modulate NK cells in more detail? We also then compared the delta NK cells to other diseases. For example, in general viral hepatitis, we investigated imprints of NK cells in the context of hepatitis C virus infection, and also in the terms of NUC-stop approaches in hepatitis B. There are differences. My message is here, the NK cells in delta are not similar to most other hepatitis viruses, but there are common imprints also, which are simply associated with exhaustion and chronic inflammation. Then we went on and investigated mate cells. And I think this story is probably very interesting and should be followed more. The mate cells are depleted in many infectious diseases from the liver. They have really a lower frequency. They were activated in phenotype, but functionally really, really weak. And that was also importantly associated with the stage of liver disease and fibrosis. So understanding these innate immune cells in the liver will be critical. Also stories, Sabila was with Malamaini, she just published or she presented at EASL very nice data that CD8 T cells may catch CD14 from macrophages in the liver, and by this, when they carry CD14, they are activated, for example, by bacterial products from in the portal vein. And when we look then into our mate cells and ascites in the liver, they are all CD14 positive. So they may play really a critical role also in the pathogenesis of liver disease. And that's certainly something where we should keep all an eye on. And then obviously everybody was looking to virus-specific T cells. 5 years ago, we published that, yes, not surprisingly, that we had weak HDV-specific T cells. We could not restore them in vitro by checkpoint inhibition, but by third signal cytokines. And then other groups also went on, investigated T cells, in particular Christoph Neumann-Hefelin from Freiburg. He published a gastro paper in 2019 showing that we also have immune escape, that these CD8 T cells really put pressure on the virus and that immune escape may occur. And Helene Kefalakis was working with Barbara Rehrmann until last year. She's now joined us in Hanover. And she basically, from another perspective, observes the same thing, that you have severely exhausted virus-specific T cells in delta, much more exhausted than, for example, CMV, EBV, or HBV-specific cells. And if they are not exhausted, have a good phenotype, then you have immune escape here. So immune escape in delta is important for adaptive immune responses. And then in addition, Helene published last year in Gastroenterology that not only HDV-specific T cells are important, but that she characterized liver-resident bystander CD8 T cells, that they really contributed to the pathogenesis of liver disease. We may talk during the discussion in more detail about this study. Again, confirming that we need to investigate not only one individual immune cell explaining the entire story. Immunology is a system. We have many cells which may speak to each other, which may interact each other. And if we want to intervene here therapeutically, we really have to understand the entire spectrum. And this is what we're trying to resolve in Hanover. We have a distinct local research excellence cluster, but also we've been just granted with the European Union project, what we call DSolve, together with the Karolinska Institute, where we basically characterize our patients and then do the usual thing, single cell attack, RNA sequencing, etc. We do liver fine needle aspirates, and then we can hopefully get a better insight. And this is Yang Li. She is a data scientist working at this institute close to MRH I showed you in the first picture. And with her, we're doing all this translational research together with Markus Kornberg, Helene, and Lisa Sandmann. Now let's coming back to Victor. So Victor, obviously, we all agree, Victor needs treatment, right? So Victor has a problem and we cannot leave him alone. And which options do we have? So he is on tenofovir. So shall we just continue and at least protect B? Shall we give him interferon? In Germany, I can prescribe bulevirtide. Should I combine bulevirtide with interferon, or are there any other treatment options for Victor available? And this is what I would like to discuss with you in the next minutes. First of all, obviously, we give tenofovir backbone treatment in this patient, but in the long term, in most patients, it may not lead to complete decline, even though, similar in line with the APNT paper, some patients may lose HDV RNA over time. We don't know why. We don't know what was the trigger, but some patients may lose it. This has been shown from the Swiss HIV cohort, as you can see here, but in terms of S antigen, nothing is happening. And those patients receiving NUCs alone don't have a good long-term cause in delta. Obviously, this is often biased, that a patient that received tenofovir only versus, for example, interferon may have contraindications for interferon. Therefore, this data is biased. But I want to highlight here, this is data from Essen, where I've been working before I went back to Hanover, that the outcome in this cohort with NUCs alone was really poor. Therefore, obviously, interferon is the treatment of choice in this patient. 10 years ago, we published that roughly 25% of patients may benefit from interferon treatment in the long term. I'm showing you this old data because we published the 10 years follow-up last year of that trial. And I want to highlight only one patient, and that is patient 207. Patient 207 was HDV RNA negative at the end of treatment over time, and she relapsed 7 years after stopping the drug. 7 years later, it was the same virus. We sequenced the virus. It was not a de novo, a new infection. The same virus came back. So in hepatitis C, you are all used to cure of HCV infection. You give the drugs you stop replication for 8 to 12 weeks, and the virus is gone. I would even take myself a blood transfusion from a post-HCV patient. And Delta would not do this because some virus is still swimming around, and therefore, if you see a patient, you have to follow him, even though he responded to treatment. And this, in the first trial, patients were tortured for 1 year with interferon. If you torture patients for 2 years with interferon, this does also not prevent relapse, which we published in Lancet ID 3 years ago. Even 2 years of interferon do not really help. I skipped this for time reasons. If you treated delta patients with interferon, there may be a surprise that we observed patients that were treated with tenofovir and interferon, and then they increased at week 12 to 24 HBV DNA. They were taking tenofovir. You may argue, what's going on? Is HBV replication increased? This is really strange. And the message here is, don't worry, just continue. This is just a marker of cell death. You're inducing interferon treatment, cells are released, and they release some HBV DNA, which is with a highly sensitive assay detected. So no worries. And an increase of HBV DNA during interferon treatment of delta is a good thing, because this is associated with a better long-term outcome, indicating death of infected cells. Just to let you know, I think this is because a fellow came to in my office, the patients are not compliant, they are stopping taking tenofovir, I want to take him out of the trial, this is a bad guy. And then I had to argue with the fellow to keep the patient in the trial, actually. It was just a phenomenon which was not expected at that time. If the patient is tolerating interferon, and if it works, you're really improving the long-term outcome. And there's data from France, there's data from here, from Hanover, from Ankara, from Milan, from King's. Yes, and response to treatment is associated with an improved outcome. This is just our graphs. So Victor may benefit from interferon. It's quite clear. So we should give it a trial if no alternatives are available. There's no doubt. However, if interferon does not work or if it's not available, then it's a question, what can we do? And this is the last part. Bulevirtide has been approved by the European Medical Agency on July 31st in 2020, and I can prescribe it in my country. What is bulevirtide? Bulevirtide is a peptide. It's a 47 amino acid lipopeptide derived from the pre-S1 region of the large hepatitis B surface antigen. So that is the region where the particle of the hepatitis B virus is binding to its receptor. And the receptor is NTCP, identified 2012, and NTCP is a bile salt transporter. So basically it's a peptide which is slightly modified. This peptide goes to the liver, binds the hepatocytes, interferes with NTCP, and then is blocking particles to enter the cell. So it's an entry inhibitor. It needs injections. It needs daily injections, 2 milligrams per day, and it's very well tolerated. So this has been developed by Stefan Urban. The first Nature Biotech paper where it was shown that it blocks entry was already published in 2008, before the receptor actually was known, which is quite interesting. And this drug received this conditional approval by medical agencies, European Medical Agency, based on a phase 2 trial only, because there was 24 weeks of treatment, and you can see here that HDV RNA declines when you apply this drug. And this decline is simply reflecting loss of infected cells, because we have to keep in mind this drug is not interfering with the HDV life cycle. So it's not interfering with replication per se, it's just protecting not yet infected cells of becoming infected. So the decline is loss of infected cells. And liver enzymes also improve here. The interesting thing was there, loss of infected cell, HDV RNA is declining, but S antigen, which is swimming around in the blood, is completely unaffected. And that gave food for thought. Why? How can this happen? If you lose infected cells, as indicated by delta, but the surface antigen is stable. And the only explanation, I think, is that this S antigen, what we are measuring in delta, is to a large extent not coming from truly infected cells, but from integrates into the human genome. So not reflecting infection per se, it's just S antigen produced from integrates into the human genome, which I think is important also when you think about cure strategies for hepatitis B. That's very hard to get rid of this S antigen in the long term. And then a phase 3 trial was initiated, and last Thursday I could present for the very first time the primary endpoint of a phase 3 trial in hepatitis D virus infection, by the way, which was very nice, with Mario Resetto being the chair of that session. And Mario Resetto described 45 years ago the delta antigen for the first time. So basically the guy who for the first time described delta antigen was sharing a session where the first phase 3 data ever were presented, which I think was quite remarkable for Mario also at that time. And you can see here this primary endpoint was a combined endpoint, so virological response together with biochemical response, and half of the patients reached both points. If you look to virological response alone, it was even 75% of patients showing this at least 2-log decline, which I think is quite remarkable. And I'm showing you this graph, which I did not show last Thursday in the general session, by purpose, because it shows that all subgroups benefit. It's not, for example, that cirrhotics patients do respond less well. They respond equally well as the non-cirrhotic patients, as to be expected by the mode of action, because we're not interfering with intracellular pathways where other factors may. We're just talking about loss of infected cell. And I think that is reassuring also for patients. And then obviously, how long can you treat? Pietro Lambertico published cases where they treated 3 years, where it was safe. What I like here at this case, that long-term treatment is really beneficial. You can see here in this case, the liver stiffness values declined from 17 to 10 over time. So really the patient is benefiting from this long-term treatment. And there has been a lot of real-world data presented from France. This is data from Germany over time. FIB4 scores decline, no surprise. And there were, in all the real-world data, roughly 10 to 20% that did not show a 1-log decline after 24 weeks. So there are some patients with suboptimal response. We have to understand what is the mechanism, but it's definitely interesting. And then we ask that we presented also at EASL. So if you're blocking a bile salt transporter, bile salts will increase during treatment. It's quite clear. You see this. Then obviously the increase in bile salts should reflect blocking of NTCP, and that obviously should also reflect how efficient your entry inhibition is. Therefore, our hypothesis was increase in bile salts during treatment correlate with virological response. And the answer is it was absolutely not the case. Not at all. There was no correlation. What correlated, and that is shown here, were baseline bile salts levels. So in some patients, they already increased, and that correlated with subsequent virological decline. which is interesting. I could now speculate 2 hours on this observation, and we have to think about bile salts physiology, turnover of NTCP. What does it mean if I have higher or lower bile salts levels? I think overall it fits in the overall concept. But again, this shows you it's now really cool that we can ask questions we wouldn't have asked before if these drugs would not be available. We understand much more about liver disease, bile salt physiology, and by the way, these bile salts increase, but the patients don't itch. So bile salt increase does not cause itching. It's very important also for the young fellows. Now, what's about few words in the end? I'm talking too long, but is together with interferon also. Can we combine both? There has been a phase 3 trial suggesting that there may be on-treatment synergistic benefit. These are the combination arms. But I have to highlight that post-treatment, many patients relapsed unless they lost S antigen in addition. And I showed you monotherapy with bulevirtide, no change in S. Combination with interferon, some patients have an S decline, and that is good. But if you don't lose S, in most patients, RNA comes back. And this is the reason why I'm currently in Germany not treating interferon together with bulevirtide. I want to wait for more data, and the trial is ongoing here. And I skip, for time reasons, again, more of this data. So very lastly, what happened then to Victor? We tried interferon, but he couldn't tolerate this. So bulevirtide was started. Was the drug safe? This is the increase in bile salts I was mentioning, which occurs immediately, dose dependent. When you stop, the bile salts go back to normal. Overall, this is the safety data I presented last week. It was really safe. There were no unexpected side effects, no drug discontinuations due to SAEs, which is really remarkable. Yes, they have to inject peptide on a daily basis, but not too severe. What you observe sometimes are these T-cell driven allergic cutaneous reactions. You can treat them with topical steroids. It's manageable, but it's more than just, let's say, tiny little bleeding here. It's really a T-cell driven allergic reaction, but this should not lead to drug discontinuation. So you can imagine here, this is, he had a viral decline. The question is now, how long shall I torture or treat bulevirtide? Can I stop? And there basically were 2 cases presented at EASL. The one is where Pietro Lamberti stopped one of his 3 years patients, and he did a biopsy 48 weeks after stopping treatment, and there was no antigen left. Complete response, cured maybe, after 3 years of monotherapy. But Peter Ferenczi from Vienna published this case where they also stopped and they observed a relapse 60 weeks after stopping. So again, the question is what is happening. We have to simply wait and see more patients. And lastly, if Victor would have not responded, there are also alternatives in development. Lorlatinib is a prenylation inhibitor. A phase 3 trial is ongoing, and we expect study results by the end of this year, early next year. That would be an alternative. You may also combine lorlatinib with interferon lambda. A trial has been performed at the NIH. Also something which is explored right now, interferon lambda monotherapy is currently being explored. And there have been data on nucleic acid polymers with block excretion of S antigen, which is also interesting, but which may be associated with severe ALT flare. So we simply have to wait here for more data. The good news for the patients, there's more in development. And obviously, if a patient would lose S antigen, cure hepatitis B, this would be the best for the patients. So that is the last data slide. I think we have really novel treatment options. We have new treatment options with lorlatinib, with lambda, with NAPS, but bulevirtide has been approved. It will be hopefully becoming available soon in more European countries. And if you are interested in data, want to learn more about Delta, Pietro and myself invite you to Milan in October, where will be the first hepatitis Delta cure meeting. And I thank you very much for your invitation. It was a great day. Thank you, Sabela.
Thank you.
I think it's very important that you mentioned also your experience. There are these cases. They are not super frequent, but these cases can occur. And I mentioned that one. And that's what the reason why I biopsied Victor, because even though he had liver cirrhosis, because otherwise, why in the hell to take a risk to biopsy cirrhotic patients? I wanted to be sure that Victor had no autoimmune hepatitis, and to be absolutely sure from the features. And that's the reason why I then started interferon. If there would have been a clear pattern of autoimmune hepatitis, then I may have, in my case, first go for bulevirtide. But the problem is the pathologist. You really have to talk to your pathologist, and that he's not answering, well, this in the clinical context could be associated with some features of autoimmunity, unless, and then they're asking back. So you really have to change and have to talk to your pathologist that you get really the information that you need for your clinical decision. That's the point. But, and also with Pietro in his cases, I didn't have the time to show you that the IgG levels with bulevirtide really went down much faster than expected, as this would be the polyglobal cirrhotic hypergammaglobulinemia. So it was really within 8 weeks a sharp decline, which I think was impressive. So the answer is yes, we should not forget that autoimmunity may occur, even though it's not super frequent. So the latency of delta in the liver is something that has been also observed in the transplant setting. So if you transplant a patient with hepatitis delta, the new liver, which hasn't seen delta before, becomes infected at the time of transplantation. And then we showed that even after several years, you can detect delta antigen in the liver in the absence of S antigen. So delta may really hide. And what is also important, hepatitis B during cell division is usually lost. While delta, there may be even a propagation of delta to the two daughter cells. And that is really something, also the patient not responding to bulevirtide. So why? There are two options. On the one hand, you have not complete saturation of NTCP, or you have something else ongoing, that is cell-to-cell spread, which you are not blocking. Their interferon may have a role. And therefore, I like the idea of a patient not responding to bulevirtide, for example, after 24 weeks, then to add interferon. Because then you interfere with the second mode of action and to keep the cell-to-cell, to keep NTCP blockade and then add interferon. That's all I can say. Delta is super infectious. And that's also what Franco Negro showed already at the NIH 35 years ago, that very, very tiny little amount of delta are sufficient to cause ongoing replication. And again, we sequenced this virus, it was the same virus. There was no de novo infection in the family or something like this. No, obviously, this was, we always get these questions. Why 2 log? Why 1 log? Why 3 logs? Why not negative? At what time 2 log? Why after 48 weeks? And so on. I think there is indirect evidence from interferon trials, Patricia Facci, that the relative decline is leading to a clinical improvement. And I think I have to applaud EMA and FDA that they took this decision, because this is just reasonable thinking. What do you want from a drug like this? It's an orphan disease. We cannot wait for 30 years to prove that 2 log decline translates in a better endpoint. So we want something that is relevant for the patient, and that is normalization of liver enzymes. As a hepatologist, I believe in normal liver enzymes. It's a good thing. So if this is declining, and I think we don't question that one. And the second thing, you're talking about a drug interfering with the life cycle, not direct acting viral, but with entry. So you want to have something to prove mode of action, and that is viral decline. And 2 log decline was a compromise. Let's say you could have argued maybe 1 log is decline. The label of EMA is even better. It allows you to treat as long as there is clinical benefit. What is clinical benefit, right? So that's the statement. And I have one patient that was a clear non-responder, both biochemical and virological. So he started off, I think, with 100,000, went down to 10,000 and increased to 30,000. So less than 1 log decline. He started off with liver enzymes of 220, and he did not normalize, but he went down to 70. So he has, for some reason, he is not becoming negative. I don't know why. He is on a plateau. But his liver enzymes really improved, and I continue this patient. Why in the hell should I stop? But I agree, he did not fulfill this response criteria, and therefore I showed here 45%. Virological response, 2 log decline was achieved by 75%. So the far majority of patients has a benefit in my view, but I agree the 2 log story is, is artificial, but I think it's reasonable. Tulloch is obviously, I think the more the better. That's quite clear, but I don't ask for negativity. I think that's too much with this mode of action. It's different than from HCV. The other thing is, you could argue, why a log decline? Why not reaching a cutoff? Why can I not define 1,000 or 10,000? But again, here also then we have the issue with the absolute values which are mentioned, and the relative decline. Then you don't have issues between assays, between labs. I think that is consistent, at least within one text. But in the long term, it may be that we end up with a distinct cutoff, that 1,000 is sufficient. I don't know. No, I 100% agree. I think we should. I think bulevirtide is a perfect backbone. It's a backbone to protect the not yet infected cells. Okay. And we need to work on what's happening in the infected cell. And there obviously are different strategies. Also, lonafanib is not an antiviral per se. It's blocking, let's say, the package and release of the cell. Yeah. But in the cell, RNA is even accumulating. And, exactly. And maybe the effect is simply that you induce more innate immunity by more RNA in the cell. Exactly. This could well be the case. Therefore, I think alternative approaches, you mentioned one idea, to interfere directly with the life cycle on a different level, this is what we need, no doubt. And then maybe my 7 years later relapse will not occur. To answer your second question, no. Okay. So there have been 2 or 3 papers. So the response factors to interferon, there will be soon a review paper out in Liver International, where with Lisa Sandman we summarized all the factors, virus factors, and the genotype, the lambda. There is one small paper from Turkey suggesting a weak association. Others do not, and we don't see this in our cohort. So lambda doesn't work. Second mode of action. Yes, the side effect profile better. The different interferon subtypes. There's been also a screening of, let's say, even interferon alpha. We have 2A currently, but what's about the other interferon? We have been using 2B. What's about 4, 5, 6, 7, 14? What's about lambda? There may be differences, and there are studies performing a screen also of interferon, different subtypes. But in vitro and also in the mouse model from Maura Dandri, there was a paper 4 years ago. In the mouse model, the antiviral efficacy between alpha 2A and lambda was pretty much in the same range. So there's no dramatic difference. I think if lambda has a chance, then it's really the side effect profile. But there we also have to be careful. The trials in hepatitis C had also some bilirubin increases 15 years ago. And it first has to be shown that it's really safer in Delta, but the phase 3 trial will answer this one. And the trial is opening and is in some countries already recruiting. Easy trial design. I think we need this trial. It's very good that the company is doing this trial, and we simply have to wait for the outcome. I think that is really needed in the field, and that's why I showed you the studies on the innate immune cells, NK cells. We need to understand that we really need to stimulate immunity. We need to understand this. In that three patients from Pietro Lambertico over 3 years, Antonio Bertoletti studied interferon gamma responses, just T cell with overlapping peptide, the usual thing. And the idea would have been, oh, you reduce viral load, you are negative for 2 years, and then an antiviral T cell response is coming back. At least measured by gamma, there was nothing. There was not a single spot in the ELISpot assay even after 3 years. And therefore, let's say my hope would not be to induce an HDV-specific CD8 T cell response. I think we need to understand a little more the innate immune cells and what is interferon doing in Delta. I think it's probably but one part of this one is spreading cell to cell, but in addition is activating innate immune cells. And then by this leads to some kind of cell death. And this is what we need to understand and to control. It's very nice. It's interesting. It's speculation. I have no answer, and I think we need to understand this. Therefore, these studies, like you are performing here in Barcelona, I think are very important, and we have to observe this. We have to think about this. It's well possible what you have been suggesting, but area of research. So for the young guys, go to Delta. There's a lot of space. We can learn a lot. It's interesting. And also with bulevirtide, it's a major step forward, but it's not all done, as I can show you. So it's not that. It's worthwhile further investing in Delta.
Thanks. So I don't see any further questions online. And if there's no other question here in the room, I think it's time to wrap up because we don't want you to miss your connecting flight. So thank you very much again for being here today and for this amazing discussion. Thank you, Heiner.
Thank you.